CICS Task Flow Recorder, TFR, is a software tool that records the full program flow, commands, database calls, parameters, and event sequence for selected CICS tasks. With TFR, tasks are recorded while running normally, no breakpoints, no step-by-step debugging. TFR tells you the exact whereabouts of a task, including its mirror tasks that ran in other CICS regions. TFR can compare tasks and point out differences in the execution flow. TFR displays the exact time spent in each linked or called program. TFR provides a task summary that shows the total number of times each distinct command took place and percentage of time spent in each module. When the recorded task reads a VSAM record, creates a container, or passes a COM area, TFR displays their values mapped by their COBOL structures, copybooks. When the recorded task issues SQL DB2 commands, TFR displays the result set, field by field, as well as the SQL statement itself. When several tasks run at the same time and communicate with each other, TFR can display their execution flows side by side in a single chronologically ordered list. If they ran into a deadlock, TFR shows you how and why it happened. If a transaction usually runs fine but hangs up or upends in some rare situations, it is practically impossible to find the problem using a regular debugger. When you run the problematic transaction with a debugger, you are likely to get the regular case, not the rare one. With TFR, you simply record hundreds of instances of the transaction and then focus on the problematic cases. You may also let TFR compare a bad instance to a good one and pinpoint the differences. Invoke TFR web application and log in with your CICS user ID and password. TFR displays the list of your previous recording sessions. We click the New Session tab. TFR displays the session submission form. Here you specify what and how you want to record. The transaction ID, up to 3 of them, each may end with a wildcard. User ID, terminal ID, IP address, or a combination of these fields, duration of the recording, and the maximum number of tasks. You may ask TFR to retain only transactions that appended or hung up. TFR can also record the content of COM area passed between programs, VSAM records that were written or read, database rows that were inserted or selected, the TIOA of send or receive commands, temp storage or transient data queue items and containers. Recording is performed in all selected CICS regions. You may choose one program for variable tracing or full working storage snapshots. TFR displays the list of all working storage and linkage section variables of the selected program, and you may pick up to 5 of them. You may also check Snapshot Whole Working Storage. The form is ready. Click Begin Recording to activate the product. TFR displays the session status page. Click the Refresh button. TFR updates the task counts in each region. At any time during the recording session, you may examine the tasks recorded so far. Click the Stop button to end the session. Click Tasks to see the list of recorded tasks. For each task, TFR displays the start time, Tran ID, User ID, elapsed time in microseconds, number of events. Facility can be the terminal ID, web, MRO for a mirror task, or start for a started task. The region, system ID, task number, and notes. If the task ends with return trans ID, TFR displays the next trans ID. If the task received COM area, TFR displays its length. If the task was started with a PF key other than enter, TFR displays key. If the program for which you asked for variable trace or working storage snapshots was invoked by the task, TFR notes it. For each mirror task, you can see the task number of its originator. For a started task 2, you can see the task number of its originator. The number of TCB switches that occurred during the task's lifetime. Let's click the Events button to see the execution flow of the selected task. Commands that were performed by CICS itself and are not part of your program code are listed in brown color. The read command obtained a record from a VSAM file. Click the Record button to see its content. Hex presentation is available too. You can even see the record mapped by its COBOL copybook. For the Send Map command, you can see the TIOA. TFR displays the EIB resp of each command. The program issued Return Trans ID, you can see the COM area. Let's examine another task. Transaction TST1 executed 345 events. It also spawned a mirror task which started its own mirror child. The event list of the parent task will include the events from all its descendants. Please note the sequence column 1, 2, 3, 4, 5, 6, 172, 173, 183. The missing numbers represents events that occurred inside the linked programs. When we click the plus icon, TFR reveals those hidden events. The linked program issues a write queue. You can see the item. The program issued return. CICS inserted a get main and a free main and returned to the calling program. Please note the changing indentation level in the program name column. For each command, TFR displays its major operand. For read, it's the file name. For start, it's the trans ID. For link, it's the program name. For delete queue, TS, it's the queue name. The elapsed before column displays the number of microseconds between the end of the previous event and the beginning of the current. The elapsed during columns displays the time during the execution of the command. This link is a remote link. It spawned a mirror task in the target region. When we open up its details, we see the event list of the mirror, which was recorded separately in the other region. TFR marks mirror events using gray background. The mirror issued a local link to another program within the same mirror. The other program issued a remote link and therefore spawned a new mirror in the third region. The grandchild mirror is marked with a darker gray background. And now a great-grandchild mirror is created. As mirrors begin to return, the background color gets brighter and brighter. Let's focus on a dynamic call to program TST005T. We have a surprise here. In addition to all CICS commands, we also see the names of the COBOL paragraphs and sections that the program performed. Here is a section name, which was performed 6 times. The program issues a static call to another program, which is linked inside the same load module. This program, too, was compiled in such a way that TFR knows each and every COBOL label that is being visited. Another link. If you hate clicking so many plus icons, you can click Expand All and see all the events within all called or linked programs. The complete story of the task unfolds. Every COM area. Every TSQ item. Let's examine a task that contains DB2 SQL statements. The main program links to TST007T. The target program issues several SQL statements. The first one caused a TCB switch. You can see the full SQL statement, and you can see the values of the columns in the results set. Social Security number, name, city, gender, date of birth. Another row. An insert statement, the SQL, and the values. This line only contains an SQL button. That's because no rows were selected. We received SQL code 100, and it happened 3 times. Let's close the task and examine another one. Event list of a task that invoked the program for which we asked for variable tracing and full working storage snapshots. The additional column on the right shows the names and values of the variables we had selected for tracing. Current group and WS length are in the working storage. The other 2 variables are defined in the linkage section and have no addressability when the program begins. Later on, the read command set addressability for the record that contains these variables, and from now on, they do have a value. Let's click the WS button. TFR displays the complete working storage at the time of the selected command. The Delta WS button displays only the variables that changed between the previous snapshot and the current one. Now you can see at which point in time each variable was assigned to a certain value. Let's open up a couple of them. The complete working storage. Let's examine a task that updated a VSAM file. The task issued a start browse, 2 read next commands, read for update, and a rewrite. Let's look at the rewritten record and map it by its associated COBOL copybook. We see the full record, field by field. We can also see the original record that was read. Let's compare the 2 different records in order to figure out which fields had been modified. Check the diff checkbox on both records and click the diff button. TFR asks for the copybook name by which the records are mapped. The record comparison report is presented. The only field that changed is the owner SSN. We can see the value before and after. Back in the task list, TFR recorded 4 instances of transaction TST2. Let's pick 2 of them and ask TFR to compare them for us. Here is the diff report. Both tasks started the same way, till the first task issued an XCTL command, while the other issued a link to the same program. As a result, CICS releases the program that issued XCTL and is not doing so in the other task because the linking program will regain control later. Now, both tasks perform the code of invoked program and seem to be doing pretty much the same thing, until the program issues a return command. In the case of XCTL, the return ends the task. In the case of link, control returned to the calling program, which happened to be a dynamically called subroutine. It issues a go back, and control returns to the main. That was the end of the comparison report. Let's look at some long-running tasks that had been communicating with each other and try to understand when and how control had been passed among them. We select the tasks and click Merge. TFR displays the execution flow of the selected tasks side by side, in chronological order. The accumulated elapsed columns shows the time since the beginning of the first task. The first task issued NQA, NQB, and a delay of 4 seconds. The third task began. When it issued NQA, it blocked because resource A is held by the first task. Task number 4 begins running until it too issues NQA and blocks. None of the tasks receives control until the delay period of task 1 expires. It issues DQ and NQ again and blocks itself. The longest waiting task receives control and runs till it blocks itself again. This control ping-pong continues on and on until task number 2 begins. It issues set task 284 purge and causes the first task to abend. We see 2 return commands. That's because the task contained a mirror and both of them had to return and complete. The remaining tasks continue running until they finally end. TFR provides summary information for each recorded task. Click the Summary button of the selected task. The count column shows the number of times each command executed. The name program TST001T issued dynamic call to TST002T twice. The called program read twice from file TSTACC The subroutine spent 57% of its runtime in these read commands. This time is also measured as 9.3% of the total execution time of the task. (16% of the task runtime was spent in that subroutine. EVR displays the total elapsed time of the task in microseconds and how much of that time was spent inside the program code itself, as opposed to CICS, database, and system services. The same figure is calculated for every module. You can see its total elapsed time and the total time spent inside program code. Program TST002T ran 219 microseconds. 109 of them were spent performing program code. Let's examine the summary of a task with lots of read and rewrite commands. Most of the time was spent in these few commands, whereas the elapsed time spent inside the code was very little. Earlier, we compared two tasks that were recorded in the same recording session. TFR allows us to compare the execution flow of a task that was recorded yesterday with a task that was recorded today. In the task list page, select one task to compare and click the diff button. A message appears. Diff operation is pending a selection of a second task. Close the task list and open the task list of the other recording session. The message diff operation is pending is shown to remind you that TFR is waiting for your second selection. Pick the second task and click diff. TFR displays the comparison report between the task that ran today and the one that ran yesterday. When both tasks issue the exact same command, but execution time varies significantly, the line is marked in yellow color. This COBOL paragraph was performed 6 times in one task and 5 times in the other. Suspend command issued 4 times in one task and 2 times in the other. Both tasks issued inquire terminal, but the operand was different. Both tasks read from the same file, but one task succeeded and the other task got a not found response. The second task issued write queue TD, and the first one did not. A few more differences. Back to the session list page, click Users to see all the user IDs that submitted recording sessions. You can select any of them and examine their session's result. TFR comes with a 30-70 user interface as well. From the homepage, select L to list all of your recording sessions. Display the attributes of a session of your choice. The screen resembles the session submission form from the web interface. Pretty much the same attributes can be selected here, except working storage trace. Click PF6 for the recorded task list. Select a task to see its event list. Select a line with content in order to see that record, in a hexadecimal as well. Select a link or call command to expand it. Here is a program whose COBOL labels are shown as well. Let's move on to another task. This task issued DB2 SQL statements. We can see the result set, field by field, and the SQL statement itself. Scroll to the next records. Let's go back to our previous task. From the event list, you can ask to see the task summary. Just like in the web interface, you see the number of times each distinct command was performed and the total amount of time spent in each module. Thanks for watching.